All right, now I want to do the covariance. I'm going to do it under here because I'm running out of room and in one screen. And so again, this is like before, I'm just running through the formula. Equals $2 1 divided by $2 minus 1, so that's still the same. And then I look carefully at this formula. And what this formula is doing is it's taking the numbers in these cells, subtracting the mean, and then multiplying by the second one minus its mean, and so forth. So I think what I need before I keep going is I think I need here the terms. Covariance terms. So I can just sum it up as I did before. So what do I want? I want what's in C2, and I want to subtract the mean, and I'm this time I'm not going to make a mistake. So this is going to be the mean is over in I2. So and I have to do the dollar symbol here like this, $2, so it doesn't scroll. And then I want to multiply that times C3, the product of C3 minus its mean, which is in J2. So $J, $2, because that should stay the same. I don't want that to scroll. When I don't want that to scroll, liberally put dollar symbols around stuff, as you saw me do. So that's the first term. And then looks like this got the same pattern. So I just go like this, and that gives me all the terms. And then if I want the covariance, I want to multiply by the sum of those terms. So that's C6 to H6. And that will add those up. And I get 17.6. And if I divide that by 100, I feel like they have 1,000 here, not 100, but it's 17.6. This should be 17.6%, and so they look like they have something else. They've divided by 1,000. They are not correct. That's not correct because that's not right. Okay, so that's that piece. Let me see if I got all of your pieces. That's it. You know, there's one more. I saw one floating down there. So let me do that last one. The correlation. So this is the Pearson. These things have a lot of meaning. I don't know if you're catching the meaning of these guys, but they are what we call statistics. They tell us something about what's going on. The variance is really super important. It tells you if you're assuming a normal distribution. It tells you how wide that normal distribution is. So these things are super important. And they give you confidence intervals. So I don't know how much of stats they're going to go into. It bothers me a little bit to do it like this, but all right. Super easy here. They want the correlation between the two. You already have all these numbers here. They want the actual correlation. And so you would take these numbers and correlation A and B, and you would plug these things in. So I have no idea why they're doing this by 1,000, but I4 divided by 1,000 is your numerator, divided by then the 0.098, which is right up here. That's the standard deviation. That's M2 divided by 100. That is actually correct. Times, and then the point, this N2 divided by 100. And you want it divided by that whole thing. So I'm going to put parentheses around that. And let's see what that gives me. Still gives me, what did I do? I did N2 divided by 100. Looks like these are all by 1,000. No, they're by 100. It should be, I'm off by a decimal somewhere. You see it 0.13092 and 0.1. If I just scoot this over, one decimal place. It's like, it's almost like they are doing this by, yeah, something's off. I refuse to believe it's me. Something's off where the decimal place is off, and hopefully you can figure out why. So I will load this up and send it to you.